All right, today we're going to take a look at stem and leaf plots, which is probably review, so we'll go quickly through that part. And then we're going to talk about how to make a box plot, or you might have heard of it as a box and whisker plot. All right, so this is problem 8.8 on page 439 of the textbook. But the problem's here, so you don't really need to get your textbook out. It says Miss Whitney has 13 students who did extra credit assignment to raise their grade. Their scores on the assignments were as follows. Part A says, make a stem and leaf plot. So the first thing we're going to do is make a stem and leaf plot. All right, so I made a stem and leaf plot. Basically, when you make your stem and leaf plot, you look at your numbers and you decide that the leading number, or sometimes numbers, go in the stem column. So of the 45, the 4 went in the stem column. And then the 5, the ones digit, went in the leaf column. When you get to numbers like 100, sometimes you have to think about what you're doing. The 10 goes in the stem, and only the last 0 of the 100, still that ones digit. So that ones digit, or the last digit of the number, is the one that goes in the leaf column. So this is almost a complete stem and leaf plot. What I'm missing is a key. So we're going to add a key here. And the key tells me if my numbers are whole numbers or if they're decimals. So in this case, my key is going to say, I'm going to use the number 45. I don't like 33 because both the numbers are the same. That 4/5 means 45. All right, we're going to move on to box plots. All right, when you're going to make a box plot, the first thing you want to do is list your numbers from least to greatest, and you want to make sure that they all fit on one line. So go ahead and pause the video and copy down these numbers from least to greatest. All right, so the first thing we're going to do is we're going to find the median. So if you recall, the median is the middle number in a data set. So what I'm going to do is check off from end to end until I get to the middle. $89 is our middle value. What I do is circle it because it divides our set of data into two pieces, the lower half and the upper half of data. So 33 through 84 is the lower half, and 96 to 100 is the upper half. So now I'm going to use a different color, and I'm going to find the median of the upper and the lower halves. So I'm going to cross the opposite way with a different color. So now I have two middle values. So if you recall, how we find the median when we have two values is we add them together and we divide by 2. So you're going to have the same thing at the upper half too. You're going to have two middle values. So in this case, that one's a little easier. 98 plus 100 divided by 2. Well, what number is right between 98 and 100? 99. Okay, so the lower one is 63.5. So if we go back to the question, it said find the median, find the first and third quartiles. So sometimes quartile 1 is labeled like this with a Q with a sub 1, and you're written as 63.5. That's your lower quartile. And then sometimes the median is called quartile 2. That's the median. And here it's 89. And then quartile 3, in this case, was 99, and that's called the upper quartile. So in this problem, these numbers divide our data set into into 4 pieces. So our lower quartile will be between those two numbers, 60 and 67, and our upper would be between 98 and 100, which makes 33 to 60 the first quarter of data, 67 to 84 the second quarter of data, 96 to 98 the third quarter, and 100 through 100 the fourth quarter. So those are your 4 pieces of data. I know this problem didn't ask to make a box and whisker plot, but I'm going to go ahead and make one so that you can see the pieces of it. All right, so I started the number line, and I looked at the numbers that I had to include. I had to include from 33 to 100. So I thought it was appropriate to count by tens. So based on your data, you just have to decide what's appropriate to count by. Sometimes ones is, sometimes fives, sometimes tens, and sometimes you'll have to count higher than 10. So I made a number line from 30 to 100, and the numbers that are going to go on this are the lowest value in the data set and the highest. And at those two values, you're going to put a single dot. So we all know that 33 is closer to 30 than 40, so I'm going to put a dot here. I can't really see the purple one. Right there. And so I'm going to then label it as 33. So then the upper number was 100, so we know it's right at 100. And I kind of messed that up. So it looks like this, 100. And then the three numbers in between are the quartile 1, quartile 2, and quartile 3. And those are going to make the box. So the lowest one, quartile 1, was 63.5. So right in here somewhere. And I'm going to label that 63.5. And then the median was 89, so we know that's extremely close to 90. And then the upper quartile was 99, extremely close to 100. So those are the three lines that make those dividers. And then I'm just going to connect them with a box. Then the box gets connected to these dots. So our box is skewed to the right because most of the data is above 63.5, as you can see. You can also see that the numbers between 63.5 and 89, our median, are very spread apart. The box is very large in that area. So these are some of the vocabulary terms you're going to be using when you're talking about box and whisker plots, like how spread is the data, so how far apart it is. Is there an outlier? So in this case, you could kind of say that 33 is an outlier because it's so far away from 63.5 that the box and whisker plot is skewed to the right, so it's more to the right than the left. And then you might also be talking about the quarters, like what percent of the numbers in this data set were below 89? Well, you can tell because it's 2 quarters. It's this piece of the box and whisker plot and then the line. So those 2 quarters together means it's 50% of the data. So that is what a box and whisker plot looks like. Go ahead and continue the problems that you're supposed to work on today.